All right, we're going to begin our new unit, Unit 2 on linear equations, inequalities, and systems. And today what we're going to try to do is relate back to some things that you guys may have done a little bit before in algebra, writing expressions. But we're also going to be going right into how to use the expressions and equations to model a real life type of situation. And so if you look at the I can statements, we're going to learn something about what a constraint is today. We're going to tell which quantities in a situation can vary and which ones cannot. And we're going to use letters and numbers to write expressions representing the quantities in a situation. So number 1.2, how much will it cost? So the first thing that we're going to do, and if you were in class, that we were doing some brainstorming of this, and that is that we are going to imagine our class having a pizza party and plan what to do, plan what to order, and to do an estimate for what that party would cost. So just think about that right now. If we were all together planning a pizza party, how nice that would be. And think of the items you would need to buy, the supplies and the food, and estimate how much they would cost. So right here, this is just a brainstorm right here. So there's some different answers that we could put into this, but we're just brainstorming. If you're doing a pizza party, you know, what would you need? And so let's talk about, well, we would definitely need some pizza, right? And if we are going to get some pizza, we need to be thinking about, what would the cost of that be? Now, you might come to some different conclusions here. If I go to Domino's, usually I can get a large pizza for, let's say, roughly $10. And you guys are teenagers, and so if you're doing a pizza party and you're hungry, I bet you guys could probably eat close to half a pizza. And maybe we go someplace, maybe the pizza costs a little bit more, and maybe you eat a little bit less. But let's just say maybe $5 per person. All right, because if you have a $10 pizza, and if two people ate that, then that would be $5 per person. So it's just an estimate. You might agree with that or not, and you could adjust as needed. But that is going to be a little bit of a variable cost depending on how many people we have. So we're going to call that 5p for $5 per person. So the variable p is representing the number of people. All right, and then of course we're going to need some drinks. And if we have drinks, we could also come up with an estimate for that. And we might be thinking about, okay, if we bought some 12 packs of pop, or if we had some other bottles of pop. Again, you guys could be thinking about what you think an estimate per person would be. I'm just going to pick a nice round number and say, well, I bet you we could come up with something that is either $1 per person or maybe less than that. I know if you're buying something at a pop machine, it'd be a little bit more, but I think we could definitely get it for $1 per person. So let's just call it 1p. Again, it's going to be variable based on the number of people. It's not just one set cost. But then we have some things that maybe, well, actually, let's go with another thing that might be on a more of a per person. And usually you guys want something sweet. So let's talk about dessert, maybe dessert cookies. And I'm thinking if I'm going to the bakery, if I'm going to the grocery store, what would be the cost of a cookie? If I want to get a nice chocolate chip cookie, which is usually my favorite. Actually, I like the chocolate chunk cookies from Panera. They are the best. Let's say, at Panera it's going to be a little bit more, but I bet if we go to a bakery, we could get cookies for roughly 50 cents per person. And if you got a package of cookies at a grocery store, you could probably lower that price. But let's just go with that for our brainstorming right now. So 50 cents per person. And then I think we're going to have some things that are more of set costs. Like we're going to need some plates. Now we could probably try to break down plates into a per person basis, but that might get a little bit complicated. I'm thinking about if we're doing a class party, I could probably get, a package of plates for say $4. And that'll probably cover as many people as we need in class, give us a little bit extra. So let's just say that's a set cost of $4. So not a per person cost. We may need some cups for the pop, and especially if we go with the route of like 2-liter bottles, which would probably lower our drink costs. But cups, they tend to be just a little bit more. If you go solo cups or something like that. So for a class of, like 30 people, let's say that's like $6 a package. So plates is $4 package and cups, let's say $6 package. You could definitely look these things up if you want and come up with a little bit more of a dialed in estimate. And what else we need? We're definitely going to need some napkins because pizza can be messy. And napkins are a little bit cheaper. Usually you can get a big package that could be way more napkins than you really need, but a big package of them, I don't know, maybe $3 per package. So let's just say that's kind of a set cost too. We don't really need to break that down per person. So those are some things. And again, these right here, this is all just estimate. These are estimates right now. Right? So we just brainstormed some estimates, and your estimates can get more precise if you have someone that's doing a little research on this. But for the sake of the notes today, as you're watching, we're just going to kind of go with these estimates. You can adjust as needed. All right, so we can now write an equation for this. And so the equation, we're going to use the variable c because the cost is going to vary depending on, in this case, how many people we have. So if we kind of go through what we have up here, we've got $5 per person for the pizza. We've got to add on $1 per person for the drinks, 50 cents per person for the dessert, cookies, plus the plates, plus the cups, plus the napkins. And that's at least what we have right here. So that gives us a total of $6.50 per person if we combine our like terms here, 5p plus 1p plus 0.50p. So per person, so 6.50p. And then we're going to add on the set costs. So of the $4, $6, and $3 for the plates, cups, and napkins, 4 plus 6 plus 3 will give us 13. So this right here can be an equation that we could use as an estimate, as a possible just predictor of our total cost based on the amount of people that we would have in our class. All right. So throughout that process, we were actually, without even really knowing and defining it, we were talking about some constraints. So we're going to kind of dial this in a little bit with a few definitions here that maybe correspond with some of the things that we were doing in the first problem. And we're just going to, though, look at a little bit different problem here. So a ninth grade party. So thinking about this theme, ninth grade party for North Junior High Student Council is purchasing custom cupcakes and decorations. Okay, so we're going to need to be thinking about a few things here. So first off, in algebra, which was really what we're getting into now after our first unit, we're now getting into our algebraic unit, right? We have something called expressions. So expressions in an algebraic context are numbers and symbols. And sometimes those symbols are variables. Usually they are variables that are grouped together to show something. So usually to show something mathematical. So in this case, let's think about the expression. Let's say we are going to be using the cupcakes. The bakery charges $4 per cupcake. Cupcakes are a little bit more expensive. I don't know if any of you guys have gotten cupcakes from Amy's Cupcakes in downtown Hopkins, but really good cupcakes. If you haven't, stop by there sometime. And even during COVID, then you can go in there and grab a cupcake, and they're really tasty. And so, again, we're going to be thinking about an expression in this case that is $4 then per person. So in this case, N represents the number of people. All right. So N is number of people. Okay, so the expression for N represents the dollar amount for the cupcake and then the number of people, $4 per person. All right, and then we've got equations. All right, equations are used throughout algebra. All right, we talk about equations all the time. We already talked about one in the first example. So equations are statements, or a statement that showing two values or expressions that are equal. All right, so we now have equal signs when we start looking at equations, right? So student council has a $400 budget to buy the cupcakes for the party, right? So we're adding that piece. So now we have the expression that we used in the previous problem. Remember, our expression is $4 per cupcake. And then we're thinking about the number of people. But now we have a $400 budget that we need to be thinking about as well. So now we can make an equation about that, saying that $4 per cupcake has to come out to equal $400 budget. So we have two things that need to turn out to be equal to each other, and that's what an equation shows. All right, and then we have something called an inequality. Right? Inequality, we use that term all the time. We use it in a math context, and we certainly use it in more of a societal context, like we have very recently with all the work around George Floyd and the conversations we are having as a community and as a society about the inequalities that we see and that we are trying to work towards erasing. But in that context, you're talking about two things that really are either not equal or perceived to not be equal, and we're trying to make them more equal, right? We're trying to do things to make them equal. So in math, we have kind of that similar idea, in that we have a statement that shows two values. That's the word two, by the way, sorry. Two values or expressions that may or may not be equal. I say may or may not primarily because an inequality can have kind of a half equal sign if it's a less than or equal to or greater than or equal to. Generally, you're trying to show something that's not necessarily equal, and you use symbols for that. But I want to make sure that we understand that sometimes we do have that equal sign even within an inequality. So, one way we might think about the previous equation is thinking about it more of an inequality. So we can say that the student council can spend no more than $400 for cupcakes. Okay, we don't have to necessarily meet the exact budget. We could spend less than that. We could spend up to that. So no more than is really a less than or equal to sort of statement right there, which is a type of inequality. And so if we think about what that really looks like, and I really like this version of it better. Notice that this version says the same thing, just in reverse. It's got the 400 first, and 400 is greater than or equal to the 4n. But the 4n is less than or equal to 400. Notice the mouth is still opening up to the 400 in either expression, but it's this one that I really like the most. I usually like the variable part of the expression first. All right, so that is an inequality. And we have some different inequality signs, right? Less than or equal to, greater than or equal to. We have less than, we have greater than, we even have a not equal to. And so those are some symbols. And we'll come back to that as we study inequalities throughout the unit. But let's just go with that for now. And then we have something called a constraint. So a constraint is a limitation on the possible or reasonable values a quantity may have. All right, this is a word that we also hear in some different contexts. We hear the word constraint, sometimes it's referred to as something that's kind of holding you down, or like almost like I guess more of a restraint in some ways. We hear that with like seatbelts and something. So constraint is a limitation, though. All right, so we've got these different pieces I'm going to do a little highlighting here, and you might want to use your different colors if you're using Notability. So we've got expressions, we've got equations, we have inequalities, and we have constraints. Okay, so let's talk about constraints there for a second. I should have proceeded on with that a little bit more. So a couple examples, and constraints actually were built within the problem already, like the $400 limit for our budget is a constraint. $4 per cupcake is constraint as well. But there's also some constraints that can kind of exist outside of the situation as well. Like, for example, there's not an infinite amount of ninth graders that are going to show up at the party, right? So let's say there's 922 ninth graders. So we know that however we do our estimates here, we're going to end up with n having to be less than or equal to 322 people. All right, you're not going to have 5,000 ninth graders show up and have to give them all cupcakes. Right? We only have a certain amount of ninth graders. So that is a constraint within our problem that we know. It's a limitation of the amount of people. All right. Another constraint may be not just the cupcake amount, but the total budget that we have for the party. And so you're not going to also be able to spend, $4,000 on this particular party unless you get someone to give you a donation for that amount. So usually we have a budget. Everyone's got budget. Your parents have a budget. Your boss has a budget. Everyone has a budget. You have a budget. Maybe you're buying some presents this time of year. Maybe you are saving up for something that is important for you, and you have a certain budget that you have in mind for those sorts of things to be able to accomplish that. So the budget here is that the cost has to be less than or equal to 500. 500 is the maximum amount of money that we can spend. All right. So let's just think about these things that we need to consider and think about the constraints. Like I said, the constraints exist both inside of a problem and kind of around a problem. So we are now going to plan a birthday party. So we just keep on this party theme right here. Match the items to the constraints written in words to the constraints written in symbols as equations, expressions, or inequalities by drawing lines that connect the boxes. All right, so let's go ahead and do that. So the number of guests. All right, so number of guests. Look at the second column. Think about, okay, which one is talking about a constraint in words for the number of guests? Looks like right here, a 20-person maximum number of guests. That seems to make sense. And that means that the number of people has to be less than or equal to 20. Notice that's what that says there. So let's go ahead and highlight that. Number of guests, 20-person maximum, which means as a symbol, as an expression, we have n, or inequality, I should say, n has to be less than or equal to 20. All right, and then we have cost of food and drinks together. All right, it's a little tricky if you read through the problems, but I think right here we got $5.50 per person for the cost of food and drinks. We talked about that on the first page as kind of probably a per person sort of situation. So that's a constraint that we have, and 5.5n would represent that. All right, oops, let's change the colors here. To do that to green. Okay, and then let's talk about the cost of the birthday cake. Okay, so down here on the bottom says $40 for a large cake, and so that's kind of a set cost. That's not really a per person cost. That's $40 per cake. So let's go ahead and highlight that. So there we go. And then the cost of entertainment. That's something we didn't really talk about on the first page, but a good party is, of course, going to have some music, maybe some games, something like that. And we might have to pay a little bit for that. So $15 for music and $27 for games. Again, that's kind of a set cost at 27 plus 15 up here. And then finally we have, I don't know what's a good color to use. I haven't used blue. All right. The total cost. So we have up here no more than $180 total cost. So our total cost has to be less than or equal to $180. So no more than means less than or equal to. So total cost. All right. So that's what a constraint is. It's a limitation that we need to be thinking about. In this case, the different dollar amounts that we have both in budget and how much things actually cost are going to be constraints for us thinking about our total amount of cost for our party. So expressions, equations, and inequalities are mathematical models. They're mathematical representations used to describe quantities and their relationships in a real situation. So a model usually is related to a real-life situation when we hear that mathematical model. Deciding how to use numbers and letters to represent quantities, relationships, and constraints is an important part of mathematical modeling. Making assumptions about the total cost of food per person, for example, is also important in modeling. We need to come up with estimates, and we need those estimates to be reasonable. We need them to be fairly accurate. So let's wrap this up. Using our assumptions in the table, write an equation that models the total cost of the party. Okay, so let's just go through. I think we'll use C for total cost. And let's see what we've got up here. We can pretty much go right down our list here. We've got $5.50. Actually, let's go right from the top of the list. Like I had told you guys before. Let's go right to the top of the list. And we've got $27 plus $15, and that's going to be music and games, plus our $40 for the cake. And let's see, n is less than or equal to 20, c is less than or equal to 180. Okay, so those are sort of limitations around the problem, not necessarily directly within the problem. So those are sort of interesting things that we're going to kind of come back to. So we have the cost of the cake. We've got the cost of we don't have the cost of the food and drinks yet, right? We have the cost of the entertainment. So the food and drinks that we have are $5.50 per person. All right, so that last piece there. So those are the things within our cost equation that we need to consider. So let's just do a little combining of like terms here. So we've got $5.50 per person for our food and drinks, plus the other set costs, 27 plus 15 plus 40 gives us a total of $82. Okay, so the amount of food and drink per person plus our set cost, 5.5n plus 82. But we also need to be thinking about, and actually I'm going to not circle this quite yet. We need to be thinking about some constraints around the problem. And if we were doing a graph of the equation, we need to be thinking about this as well. So this is for n is less than or equal to 20 people. So we talked about that being a constraint up here, right? That the $20 the 20 amount is for people, the amount of people. So the number of people is going to have to be less than or equal to 20 for our birthday party. That is a constraint. Right? And the other constraint is going to be, struggling a little bit at the end here, is that our cost has to be less than or equal to $180 for the party budget. All right. So we talked about that up here, that the total cost right here has to be less than or equal to $180. So we need to be thinking about both of those things. When we start plugging in the amount of people that we have, we know that it has to be less than or equal to 20, but we also need to make sure that we are staying under $180 for our total budget. So both of those things are going to be important for our